Rightio, we've got a lovely looking integral here. But first of all, let's rewrite it. And the reason we're doing this is so we can use the reverse chain rule. So if we think about the sine x squared, if we were to differentiate that, we'd get 2x cos x squared. So it's going to be something along the lines of x at the front, and we'll have a 2 there as well. And then we'll have the other x squared and a half. Lovely jubbly. So now, when we go and do by parts, we can have our bit to differentiate as a half x squared. So we differentiate that, we get just x. And the bit to integrate will be the 2x sine x squared. And kind of using either inspection or reverse chain rule, it's going to look something along the lines of cos x, well, cos x squared. And there'll be a minus because of the way when we differentiate minus cos, we get sine. And if we think about now differentiating this thing, what will we get? Well, we will get 2x from the differential of this come out the front, and then the cos x squared, well, the minus cos x squared, will become sine x squared. So that's all good. So plugging this into our integral, we have u times v, so a half x squared multiplied by minus cos x squared. Take away the integral of u dash v, so that's x, and then the minus will change that to a plus, and still a cos x squared. And you can see there's going to be a very, and we still have a dx as well. And you can see there's going to be a very similar pattern to how we've integrated this. So what we'll do, we'll put a 2 out here, and then put a half out the front. So this entire integral, we can kind of do by inspection again, using the reverse chain rule. And what we get is that that's going to be plus a half of sine x squared. We can just double check by going to differentiate this thing again. So we'd get a 2x out the front, and then we'd get a cosine x squared. The 2 would cancel with this half, so we'd have an x cos x squared. Lovely jubbly. So now we'll just copy this bit down over here. Minus a half x squared cos x squared. And we'll write that as one big fraction. So we'll have the 2 on the bottom. We'll start with the positive bits. So sine x squared cos x squared all over 2. And as this is MIT's integration bee, we don't need a plus c on the end. Happy to put one if you want, but we don't need it here.